In this video, we're going to be learning about the properties of circles. We'll be learning how to label parts of the circles, so to be able to name the different parts of them, which will include learning about the radius, the diameter and the circumference, and we'll learn rules such as the diameter is twice the radius. There are 4 different activities on this worksheet and also a circle property guide which you can use to help you complete the different activities and which you should also try and study and learn. In these activities we'll be doing things such as finding the different parts of the circle when given other clues. And finally, the last activity will be to investigate different parts of the circle when presented in a word problem. So the first thing you could do is to print off the Circles a Quick Guide. This will be in the resources section on your app, and it is very useful and really important that you try and study it. This is not something that you'll just learn in year 6 and then not come across again. This will carry on all the way up to your GCSEs, so it's going to give you a really good foundation for understanding circles. So let's look at the first part of this worksheet in detail. Here we learn about 3 main parts of a circle: the radius, the diameter and the circumference. We will learn what each of these 3 parts are and also how they link to one another. So if we were to know what one of these things were, we should be able to use that clue to find out what the other things are. Okay, let's start with the radius. The radius of a circle is basically the distance from the centre of the circle to the edge. So if you took the centre of the circle and you drew a straight line to any point on the edge, it would always measure the same distance, and that's called the radius. If you look across at the diameter, you'll see that the diameter is actually a line that cuts the circle in half. That line will travel through the centre of the circle as well. If you compare it to the radius, you'll see that it's actually double the radius, and the radius is half the diameter. So the radius travels from the centre to the edge. The diameter travels from one edge to the other edge, but through the middle, through the centre of the circle. It will cut the circle in half. Now in this instance, in this example, it's cutting it across horizontally. However, it's worth noting that that line could go through diagonally, it could go from top to bottom. It doesn't have to be across the middle horizontally like that. If it passes from one edge to the other through the centre, then it is the diameter. The circumference of a circle is basically the perimeter of the circle. It's the distance all the way around the edge. So if you started at one point on the edge and you followed it all the way round till you got back to your starting point, that would be your circumference. At the bottom of that little diagram, we've got some rules. Now the first one, you'll see a funny little symbol and it says equals 3.14. That symbol is pi. Okay, it's not pi like you would eat, not a type of food. It's pi and it's written like that, spelled like that, P-I. It's actually a much longer number than this, but at this point, all you really need to remember is 3.14. The next calculation, we've got C equals pi d. What this means is that the circumference, which is represented by the letter C, is equal to pi multiplied by the diameter. This is bringing in algebra. You may or may not have completed the algebra section yet, but in algebra, when we put 2 values next to each other, we don't need to put the multiplication symbol in between them. We assume if there's 2 values next to each other, it means those 2 values need to be multiplied. So to find the circumference, you multiply pi, which is 3.14, by the diameter. And finally, the diameter is 2 times the radius. It's double the radius, and we can see how that's represented in the pictures that you can see on the screen. The diameter is double the radius. In our first activity, we're going to be finding the diameter of each circle using the clues given. If you feel confident at being able to do this already, then pause the video or skip this section and go ahead on your own. However, if you'd like a bit of help, I'm going to go through an example on your screen now. Remember to use your help box on the side. It's given you the formulas there so you don't have to remember them. Okay, we're going to start with a circle which has one part labelled. The first thing is to think about what clue do we have? What part of the circle have we got labelled? You can notice that it runs from the centre to the edge. It does not cut the circle completely in half. It doesn't run from one edge to the other. So we have the radius. So we could write down that the radius is 10 centimetres. It's always important when you're looking at any kind of problem that you think about what you do know. What clues do you have? In this instance, we only have one clue, but we know that it's the radius and that it's 10 centimetres. So looking at your formula, how does the radius link to the diameter? We can see that the radius is half of a diameter and that the diameter is 2 times the radius. So we can actually just substitute that 10 centimetres in for R in your formula box. So where it said before D equals 2R, we can put D equals 2. We're going to put a multiplication sign in now because we're not using a letter and a number. So 2 times 10 is 20. So the diameter is 20 centimetres. The next activity is to find the circumference of each circle, and then we need to round our answers to the nearest centimetres. So 2 different skills there. First of all, finding the circumference, and secondly, being able to round your answer to the nearest centimetre. So let's have a look using a different example. Again, if you feel confident, you can pause the video or skip this section and have a go on your own. But if you'd like a bit of help, we're just going to go through one example now. So I have a circle. I need to figure out what clue I've been given. So do I have the radius? Do I have the diameter? Or do I have the circumference? I know I don't have the circumference. That's what I want to find. I can see that the line cuts the circle completely in half. It goes from one edge to the other through the centre. So I actually have the diameter. So I could write down that the diameter is 8 centimetres. So if I'm looking for my circumference, what formula am I going to use from my guide? So you can see, using your guide, that the circumference is pi times the diameter. I can substitute one of those values in. Circumference is pi times 8. And now I can substitute the pi symbol. We're just going to put 3.14. I said earlier that actually the real value of pi is a lot longer than that. There are more digits, but you just need to know this for now. Okay, so we have our calculation which we'd need to do to find the circumference. Okay, so at this point, if you were going to calculate it, obviously you need to have some methods for multiplying a number by another number which has decimal places in. So I'm going to show you 2 different ways to do this if you're not sure. You can actually do this with a calculator because the skill you're learning here is being able to find the circumference. So it's understanding what to do when you've got your clue. However, if you want to push yourself a bit more, I would advise you to give it a go at actually doing the calculation as a written method. Okay, so there's 2 different ways here. I'm going to show you first of all, if I was going to do 8 times 3.14, I might partition it. I might do 8 times 3, 8 times 0.1 and 8 times 0.04. I have simply partitioned my 3.14. 8 times 3 is 24. 8 times 0.1 is 0.8. 8.8 times 0.04 is 0.32. And then I can add my numbers up. Now what I'm going to do, if I'm adding or calculating with numbers where they have different decimal places, I always just fill in the zeros, okay? So starting at the end, 0 plus 0 plus 2 is 2. 0 plus 8 plus 3 is 11. So 1, carry the 1, put my decimal point in. 4 plus the carried 1 is 5, and 2 plus nothing is 2. That's one way of doing it. Let's look at another way of doing it. So we're doing 3.14 by 8. Okay, what I'm going to do is I'm going to make my 3.14 easier to calculate with. So I'm going to actually change it to 314 by 8. So I've made it 100 times bigger. So that's a reasonably simple multiplication to do. 4 times 8 is 32. 1 times 8, 8 plus 3, 11. 3 times 8, 24, plus my 1, 25. Oops, 25. Now remember what I said earlier about we had made my number 100 times bigger because we had moved this decimal point 2 spaces to the right. So we now need to undo it by moving it 2 spaces back. So we go to our answer and we move our decimal point 2 spaces. So it needs to go there. So I'm going to pop that in. And my answer becomes 25.12, which is exactly the same as the answer we got before. So we know that it's 25.12. We need to round it to the nearest centimetre. So 25.12, you should know when rounded to the nearest centimetres is 25 centimetres. Okay, give it a go. In the next part, we're going to be finding the radius of each circle. So you need to look at the clues you've been given, think about which formula you might use to find the radius of the circle. Again, if you feel confident at having a go at this on your own, pause or skip this part of the video and give it a go. If not, we'll do an example together. Okay, so in our example, we first need to think about what clue have we been given. Is this the radius, is this the diameter, or is this the circumference? Okay, it's the outside of the circle, so that is our circumference. Have a look on your circle guide and remind yourself how the circumference links to the radius. How could we use the circumference to find the radius? Okay, so I know that I can find my circumference by multiplying the diameter by pi, and I know that I can use the diameter to find radius. So there may not be a quick step to go from circumference to radius, but you can break it down into smaller steps. So why don't we try and find the diameter first? I know that the circumference is 235.5, and I know that I can find that by multiplying pi by the diameter. Now I don't know what the diameter is, but I do know what pi is. So if something multiplied by something gives you an answer, then we can use the inverse. So actually we could do 235.5 and we can divide it by, which is 3.14, to find our diameter. Okay, so not an easy calculation to do, As I said before, you are more than welcome to use a calculator for this, because what we're trying to learn here is about how the different parts of a circle relate to each other and how you can use one clue to find another. So that's what your objective is here. So if you want to use a calculator, you can use a calculator. If you want to challenge yourself that bit more, we can have a go at seeing how you could do this calculation. As we did earlier, we try and make the numbers easier to work with. You can't divide by a decimal number. Well, you can, but it's very difficult, and especially in year 6 or even key stage 3, you don't need to be dividing by a number which has decimals in it. So we're going to try and make this 3.14 not have decimals in it. So as before, we multiplied it by 100 so that it was a whole number. So if I'm going to divide by 314, I've multiplied that number by 100. I need to do the same to my 235.5. I need to multiply that by 100 as well. So each number is going to move over to the left 2 spaces, or my decimal point is going to move. So I need to put a placeholder. Okay, so this calculation will give us our diameter. Okay, if you've done long division, you'll know that you need to make a help box. It's a good idea to make a list of all the multiples of 314. So I'm going to do that quickly now. Okay, it's very unlikely you're going to be given a calculation this difficult in your SATs paper, but it's a good skill to practice if you want to challenge yourself. Okay, you will definitely be given long division, but it won't be a decimal number and it won't be dividing by a 3-digit number. Okay, so 314 into 2 doesn't go, into 23 doesn't go, into 235 doesn't go. We've now got 2,355. We can go down our list and we can see 1, 2, 3, 4, 5, 6, 7 is going to fit in 7 times. I'm going to write what 7 times 314 is. I'm going to subtract the 2. Can't do 5 take away 8, so I'm going to borrow 1. 15 take away 8 is 7. I can't do 4 take away 9, so I'm going to borrow 1. 14 take away 9 is 5. 2 take away 1 is 1, and that is 0. I'm going to carry this down. So now I'm doing 314 into 1,570, and you can see that it is 5. Okay, so my diameter is 75. So I could actually write that bit in. Equals 75. If I know that my diameter is 75, how will I use that to find out what my radius is? I'm going to halve it because the diameter is equal to 2 times the radius. So 75 is equal to 2 times the radius. So 75 divided by 2 will equal the radius. And 75 divided by 2 is 37.5 centimetres. Okay, give it a go. In our final section, we're going to be solving word problems. Now, these word problems are just using the skills that you've just practiced, finding the circumference or diameter or a radius. However, rather than being given explicitly, it's in a word problem. So you need to figure out what clue you've got and then think about what you're being asked to find and how you can use the formulas that you've got to figure them out. So again, if you feel confident, go ahead. If you'd like a bit of help, I'm going to go through a different example now. So in this example, we have a merry-go-round measures 2 meters from the edge to the center. How far will the merry-go-round travel in one complete turn? So what do we know here? You might want to do some highlighting. You might want to think about which is the important information and what it all means. So we've got 2 meters from the edge to the center. That's quite important. What does that tell us? And how far will the merry-go-round travel in one complete turn? That's also important. So if we think about the first highlighted clue, 2 meters from the edge to the center. It doesn't go from edge to edge, it only goes from the edge to the center. So that means I know that the radius is 2 meters. How far will the merry-go-round travel in one complete turn? So that means I'm thinking about my circumference. I want to know the distance of all the way around the circle. So I want to find out what my circumference is. So what is the circumference? Okay, so we need to think about how the radius links to our circumference. So we know, using our formula, that we can find our circumference by multiplying pi, which is 3.14, times by the diameter. We don't have the diameter, but we have the radius. And we know that the diameter is 2 times the radius. We have the radius. So let's begin. The diameter is 2 multiplied by 2 meters. So the diameter is 4 meters. Okay, now that we have a diameter, we can substitute the first calculation. So we can do 3.14, which is pi, multiplied by the diameter, which we've calculated to be 4 meters. Okay, as I said before, you can use a calculator here. It's absolutely fine because we are testing you for your understanding of how the different parts of a circle relate to each other. However, if you would like to challenge yourself, then let's have a go at calculating. Now I'm going to do 314 multiplied by 4. I've made my 3.14 100 times bigger. Once I find my answer, I'll make it 100 times smaller. So 4 times 4 is 16. 1 times 4 is 4 plus the 1 is 5. 3 times 4 is 12. I want to make that 100 times smaller now. I'm simply going to count in from where the decimal point is now after the 6, and I'm going to count in 2 spaces. So it becomes 12.56. So my answer is 12.56 meters. If I needed to round it to the nearest meter, it would be 13 meters. So give it a go, have a look at your questions. Remember, think about what clue have you got? Have you been given the radius or the diameter or the circumference? Then look at what you're being asked to find and then think about how it links. Just like this problem, we couldn't go straight from the radius to the circumference. We needed to use the radius to find the diameter, and then we could use that to find the circumference. So there may be a couple of steps involved, but always look at what information you have and then look at the links, use the formulas to try and get to the bit of information that they are asking for. Okay, good luck. So well done. I hope you've learned something new, and hopefully you now understand how the radius, diameter and circumference all link together, and how when we have clues about one of those things, we can use that to find what the other things are. So when you're feeling really confident, print off the past SATs questions and have a look at the different way this kind of maths skill might be presented. Good luck.